All right, let's dive right in. Today we're talking about a huge upgrade in how AI finds answers. We're looking at a leap that basically transforms it from a simple assistant into, well, a genuine researcher. This is the world of agentic RAG.
So we've all been there, right? You ask an AI a question, and it just confidently spits out something that's completely wrong. I mean, totally off the rails. Why do these incredibly powerful tools sometimes get things so catastrophically wrong? It's a really common problem, and it points to a big limitation that, thankfully, we're finally starting to solve.
You see, the old way of doing things, which is what you're looking at here, is kind of like treating the AI as a junior researcher who you have to spoon-feed everything. You just hand it a stack of documents and say, okay, you can only use these to find the answer. And if the key piece of info isn't in that stack, well, the AI is completely stuck. It's got nowhere else to go.
So that brings us to our first section, the AI's reading list. Let's dig into exactly how this whole spoon-feeding approach, which is more formally known as naive RAG, actually works.
So what is naive RAG? That name, RAG, stands for Retrieval Augmented Generation. But in simple terms, it's a system where an AI answers your question based only on a fixed set of documents it's handed, all in one single shot. And the really crucial part here is this. The AI has absolutely zero control over the research process. It can only read what it's given. That's it.
But what if we could change that? This is where it gets exciting. Welcome to Section 2, Unchaining the AI Researcher. We are about to promote our AI from just a passive reader to a truly active, autonomous investigator.
And this slide just lays it out perfectly. On the left, you've got passive RAG. The AI is stuck inside a box with a fixed reading list. But on the right, you have agentic RAG. Here, the AI is unleashed to actively go out and explore an entire web of knowledge, finding the answer for itself. I mean, this isn't just a tiny tweak. It's a total game changer for AI autonomy.
This diagram really gets to the heart of it. You see, other advanced methods, like graph RAG or workflow RAG over on the left, they're still just following a set of fixed, pre-programmed steps. But look at agentic RAG on the right. It's the only one that can come up with its own strategy, on the fly, search over and over and decide for itself which tools to use. It's not just following our instructions anymore, it is truly in charge of the investigation.
Okay, so if the AI is now in charge, how does it actually, think? That brings us to Section 3, where we're going to look at its brand new toolkit.
So agentic RAG, or ARAG, gives the AI three core tools, and they work a lot like how you or I might do research. First, it can do a keyword search. Think of this like looking in a book's index for an exact name or a specific term. Second, it's got semantic search, which is more like browsing a whole section of the library to find related ideas and concepts. And finally, there's chunk read, which is basically pulling a promising book off the shelf and reading the whole chapter.
And this diagram just maps it all out. The agent gets a question and it starts to think. It might kick things off with a keyword search to find a specific name, which points it to a little snippet of a document. Then it might use semantic search to explore some related concepts. And based on all those clues, it uses the chunk read tool to get the full text, deciding all on its own when it's gathered enough evidence to give a confident answer.
Now, this all sounds great in theory, but does it actually work better? That is the million-dollar question, right? And we're going to tackle it in Section 4, The Agent Outperforms. And the answer is a resounding yes. Just look at this data. This is from the Hotpot QA benchmark, which is a really tough test for AIs. Naive RAG, the old way, scores about 79%. Even a more advanced method, HippoRAG, only gets to about 85%. But look at this. A simple agentic RAG just blows them away, jumping all the way to nearly 91% accuracy. That is a massive leap in performance.
But wait, here is the real kicker. It's not just more accurate, it's also way more efficient. On that exact same tough dataset, the agentic RAG model used 49% fewer tokens. So, in other words, it did almost half the amount of reading
and still got a more accurate answer. I mean, just let that sink in for a second. The AI is doing almost half the work to get a significantly better result. It's the absolute definition of working smarter, not harder.
Now, what usually happens when you solve one big problem in science, you end up revealing the next one. So let's look to the future in Section 5. What's the next bottleneck?
This quote from the research paper just sums up the new reality perfectly. The bottleneck has shifted. The core problem is no longer that the AI cannot find the right information.
The problem now is that it found the documents but reasoned incorrectly. We've given it a library card, now we have to teach it how to actually think critically about what it reads.
And this chart just drives that point home. When agentic RAG fails, look at why it fails. An absolutely overwhelming 82% of the errors are now reasoning chain errors. What that means is the AI is finding all the right puzzle pieces, but it's struggling to put them together in the right order. Finding the info just isn't the main problem anymore.
So what do these reasoning errors actually look like? Well, the single biggest culprit, making up 40% of them, is something called entity confusion. This is where the AI literally mixes up people, places, or things, even when the correct information is sitting right there in the text. It's like finding the right names in a history book but getting totally confused about who did what. Other big errors are things like using the wrong search strategy to begin with, or just not understanding a complex question.
And that leaves us with this final, crucial question. Now that our AIs have finally learned to find information like a world-class researcher, how in the world do we teach them to reason like one? Because that is the next frontier.
You know, we usually think of AI as something that analyzes data, maybe helps us write an email, but what if it could do something way more profound? Well, some recent breakthroughs suggest that AI is actually taking on one of the most intellectually demanding jobs out there, being a scientist. Just let that sink in for a second. This isn't about a fancier calculator or a better microscope. No, we are on the edge of having a genuine partner in that messy, creative, and brilliant process we call scientific discovery.
So what's really changed here? I mean, for decades, AI has been that reliable workhorse in the lab, handling all the routine stuff. But now it's stepping out of the background and taking on a real leading role.
And look, this isn't some sci-fi future we're talking about. This is happening right now. Researchers are already teaming up with advanced AIs like Google's Gemini to crack problems that have had scientists stumped for years. We're going from simple automation to actual ideation, with AI contributing to the core intellectual work.
So what does this AI teammate actually do? Well, one of its first jobs is to be an unbelievably tough critic. Think of it like an AI detective, able to spot these tiny, subtle flaws in really complex arguments that even human experts can totally miss.
To see this in action, we got to talk about something called snarks, okay? All you really need to know is that they're a type of super efficient proof. They're vital for things like blockchain security. And for decades, building them from standard, trusted assumptions has been like the holy grail of cryptography.
And then a new paper comes out claiming they'd finally done it. This was a huge deal, and it even passed the first round of human review. But something was off. There was a tiny crack in the foundation, and it would take an AI to find it.
And here is the brilliant part. The researchers didn't just ask the AI, hey, is this right? No. They put it through this intense boot camp of self-criticism. It was like a constant loop. Okay, review this. Now find the flaws in your own review. Okay, do it again and again. Don't stop until you are absolutely certain. So here's the fatal flaw the AI uncovered. The paper's entire security depended on something called perfect consistency, meaning the proofs had to be absolutely foolproof, working 100% of the time. But what the paper actually built only had statistical consistency. It was probably right, but not always right. And that tiny gap, that single point of failure, well, that was enough to bring the entire system crashing down. And the AI was the only one that saw it.
And this wasn't just some theoretical exercise. The AI's finding was sent to human experts, who confirmed it. They said, yep, that's a fatal flaw. The authors graciously acknowledged the error and updated their public paper. The AI detective had literally protected the integrity of science.
Okay, but spotting flaws, that's only half the story. The other thing AI is becoming is a kind of creative muse, connecting ideas from completely different worlds in ways that can spark just incredible breakthroughs.
I mean, think about it. A human mathematician might be a world expert in graph theory, but know next to nothing about, say, geometric functional analysis. The AI, on the other hand, it's read the textbooks for both, and everything in between. This lets it act as this incredible bridge, cross-pollinating ideas between fields in a way no single human ever could.
So take the max cut problem. It's a classic computer science challenge about the best way to divide a network. The AI solution was to just stop thinking about it as a network problem at all. Instead, it reframed it as a physics problem. How do you minimize energy on the surface of a sphere? This totally new perspective allowed it to pull in powerful tools from a completely different field of math to crack it.
And then there was this other problem with embedding graphs.
So the AI dives into its massive library of knowledge and pulls out this super obscure geometric principle, the Kerr-Strabon extension theorem. It was like finding a dusty, forgotten key in the back of a drawer that just happened to be the perfect fit for a lock that had stumped researchers for years.
So, this all sounds pretty magical, right? But how does it actually work? Well, it turns out this isn't just luck or some random chance. Researchers are developing a whole systematic playbook for how to collaborate with these new AI partners.
It's really a four-part process. It all starts with a simple back-and-forth dialogue. Then you actively ask for that cross-pollination we were just talking about. Next, you use that tough adversarial review to hunt for bugs. And finally, you can even get the AI to create automated loops where it writes code to test its own mathematical ideas. Pretty wild.
And this quote from the researchers really gets to the heart of it all. They don't see the AI as some all-knowing oracle. They describe it as a tireless, knowledgeable, and creative, bright junior collaborator. See, it's not a replacement for human scientists, it's a powerful new partner.
This diagram really brings it all together. You can see how it works. The human sets the direction, right? They provide the problem and the guidance. Then the AI just dives in, exploring this massive landscape of potential solutions. Finally, they come back together to check the results and start the loop all over again. It's this incredibly powerful, collaborative process. Now, this new way of doing science is obviously incredibly promising. But like with any powerful new technology, it also creates a whole new set of problems we have to think about. The very same researchers behind these studies flagged one huge concern, and they called it an impending crisis in peer review.
And when you think about it, it makes perfect sense. If AI can help us generate dozens of super complex new theorems every single day, who's going to check all of them? The whole bottleneck in science might shift from generating ideas to verifying them. We might actually need AI reviewers just to keep up with the AI researchers.
But hey, that's a challenge for another day. Right now, we're standing on the doorstep of a new scientific revolution. The fusion of human ingenuity and artificial intelligence is about to unlock discoveries we can barely even imagine. And it just leaves us with this one exhilarating unanswered question. With this new partnership, what problem will science solve next?
You know that feeling, right? If you're a scientist or really just anyone trying to follow research, it feels absolutely impossible to keep up. For years, we've all been hoping for an AI that could just read everything for us and give us the perfect summary. But there's been this one fatal flaw holding the whole idea back. Well, until now.
And that's really the big question here. Scientific knowledge is expanding at this incredible rate. So an AI that could actually synthesize all of that accurately, it would be a total game changer for discovery. But here's the problem. Today's most advanced AIs, well, they have a major trust problem.
And that problem boils down to this one single shocking number, 90%. Yeah, you heard that right. That's how often some of the most powerful AIs out there, we're talking about models like GPT-4o, just hallucinate or, completely invent their sources when you ask for a citation. For science, where verifiable sources are literally everything, a 90% failure rate isn't just bad. It's a complete deal breaker.
And look, this isn't a new problem, but it's getting worse, and it's getting worse fast. Researchers are basically drowning in a sea of new discoveries. Just keeping up with your own specific field is a full-time job, let alone trying to stay on top of adjacent fields where the next big breakthrough might be hiding. This information overload is a real, serious bottleneck for scientific progress.
So you see the promise, right? An AI assistant that could navigate this flood of information would be huge. But that whole beautiful promise is completely torpedoed by the hallucination problem. Because in science, a fact just isn't a fact without a source to back it up. This massive lack of trust in AI citations has made these incredibly powerful tools almost useless for any kind of serious research.
But what if you could build an AI from the ground up designed specifically to solve this problem? What if you could create a tool for science, built on the principles of science? Well, that's exactly what a team of researchers set out to do. So let's meet OpenScholar.
Now, OpenScholar is not just another general-purpose chatbot. No, this is a specialized system designed to do one thing and do it really, really well. Answer scientific questions with trustworthy answers. It's completely open source. It pulls its information from a massive database of 45 million real papers, and its entire architecture is built for one thing: accurate, verifiable citations. So how does it actually work? Well, OpenScholar uses this clever multi-stage pipeline, where every single step is designed to make sure the final answer is accurate and relevant.
It really comes down to three simple but really powerful ideas.
The best way to think about it is like having the absolute perfect research assistant. First, it has a massive library. We're talking 45 million papers. Then, it has an expert librarian, a super smart system that knows exactly how to find the most relevant passages for your question. But this next part, the writer, this is the crucial bit. It doesn't just spit out text, it drafts an answer. Then it critiques its own work against the sources, and it refines it again and again until the answer is both accurate and comprehensive.
Okay, so you've built this new system. That's great. But how do you actually prove it's better? Well, the creators of OpenScholar quickly realized that the existing tests just weren't tough enough. So they decided to build their own, a new, incredibly demanding benchmark.
It's called Scholar QA Bench, and you can forget about simple multiple-choice quizzes. We are talking about thousands of complex, nuanced questions, all written by PhD experts. These questions demand that the AI synthesizes information from multiple different papers just to even begin to form an answer. This is the real deal, real-world gauntlet for an AI scientific reasoning.
So we have our new contender, OpenScholar, and we have the new gauntlet, Scholar QA Bench. The stage is set. How would this specialized, open-source model do against the biggest names in AI, and, for that matter, against human experts? Well, the results were pretty surprising. All right, first up, answer correctness. On this really tough test, GPT-4o gets it right about 45% of the time. Not bad. But look at this. OpenScholar, even with a smaller 8 billion parameter model, which is kind of a measure of its complexity, it scores 51%. And when you combine the OpenScholar system with GPT-4o as the writer part, the score jumps all the way to 58%. But this next part is where the story gets absolutely wild. Remember that hallucination problem? On citation accuracy, GPT-4o scores a nearly non-existent 0.1%. I mean, that's basically zero. It's just guessing. OpenScholar, on the other hand, hits nearly 48% accuracy. That's approaching the level of a human expert. This isn't just a small improvement. This is a different league entirely.
Let's put this even more starkly. Let's just look at completely fabricated, made-up citations. The big models, GPT-4o and Llama 3.1, are inventing sources almost 80% of the time. And OpenScholar, zero. That's not a typo. It's not a rounding error. It's 0%. The problem of an AI just inventing non-existent papers? It's gone. This is the breakthrough.
Okay, so it beats the other AIs. That's huge. But what about the ultimate test? How does OpenScholar compare to, well, us? The final test was a blind comparison, putting its answers head-to-head against answers written by human PhD experts. So, who would other specialists prefer?
The result here is just astonishing. So they gave a separate panel of experts two anonymous answers, one from a human, one from OpenScholar. And those experts preferred the AI's response 70% of the time. They said its answers had better coverage, they were better organized, better than the answers written by their own colleagues. This isn't just matching human ability in a blind test, it's actually surpassing it.
So what does all this mean? I mean, an AI that can outperform other models and even human experts. That's not just a clever new chatbot. This is a fundamental new tool for science, and it has some really profound implications for all of us.
A tool like OpenScholar can seriously accelerate discovery by helping researchers connect the dots way faster than ever before. And because it's fully open source, this part is so important. It helps democratize science. It's available to anyone, not just locked away inside big tech companies. And maybe most importantly, it starts to restore our trust, proving that AI can be a verifiable, reliable partner in our search for knowledge.
And look, this isn't some far-off research project you might see in a decade. This is a real tool that you can go and use right now. Since its public demo launched, over 30,000 users have already started using it, asking it nearly 90,000 questions to help them navigate this ever-growing ocean of scientific data.
Which really just leaves us with this one final, fascinating question. For what feels like the first time, we actually have a tool that can reliably read, understand, and synthesize pretty much all of human scientific knowledge, seeing connections that no single human could ever hope to spot. So what's the first monumental breakthrough it's going to help us achieve?
Okay, so you've definitely heard of ChatGPT. But what happens when it goes to work for the Pentagon? Well, that's exactly what we're diving into today. The huge and, kind of controversial new partnership between OpenAI and the US military.
So, let's just get right to it. The big news?
OpenAI is officially bringing its powerful AI tools to the U.S. Department of Defense. And look, we're not talking about some small test run here. This is a major step up in their work with national security. A really big deal.
All right, so let's get into the details. Where is this all going down? It's happening on a brand new platform called GenAI.mil. We're going to break down what that is and who's involved.
And to give you a sense of just how massive this is, we're talking about 3 million people. 3 million civilian and military personnel will have access to this platform. That's an enormous number of people getting their hands on these incredibly powerful tools.
So what is GenAI.mil really? The simplest way to think about it is like a secure, private garden for AI tools, completely walled off from the public internet. It all runs on the government's own authorized cloud, built for work that's sensitive, but not top secret.
You know, this whole thing didn't just happen overnight. OpenAI and the Pentagon have been working together for a bit. They've already collaborated on things like cyber defense with DARPA and a few pilot programs with the CDAO. So this is really the next logical step in a relationship that's been growing for a while.
Okay, on to the big question. Why? Why is this happening? What's the mission here? What's the whole point of bringing ChatGPT into the military's day-to-day operations?
Well, OpenAI's official line is pretty straightforward. They're basically saying, hey, the people defending the country, they should have the best tech we can give them. It's a very clear statement that they see a role for their technology in defense, for sure.
Okay, that's the high-level justification. But you're probably wondering, what are they actually going to use it for, right? Like, what does this look like for an average person working at the Pentagon day to day?
Now, this is super important. We are not talking about battlefield AI. Not yet, anyway. For now, this is all about the less glamorous, back-office stuff. Think of it as a super smart assistant for things like summarizing those super long, dense policy docs or helping draft paperwork. The whole idea is to cut through the red tape and speed up the administrative side of things.
All right, let's talk about the elephant in the room, security. The second you put government data and AI in the same sentence, alarm bells start ringing. So, how on earth did they build a version of ChatGPT that's safe enough for the Department of Defense?
And this is where things get really interesting. Let's do a quick compare and contrast. The public ChatGPT you and I use, our data might get used to train the model. But with the GenAI.mil version, nope. That data is completely locked down. Public ChatGPT runs on regular commercial servers. This one runs inside a secure government cloud. And on top of that, it has custom-built safety features. We're talking about two totally different beasts here.
So the security really comes down to three key things. First, the whole system lives inside the government's own secure cloud. Second, any data that goes in, stays in. It is completely isolated. It never leaves that environment. And third, and this is the absolute kicker, none of that data is ever used to train the public ChatGPT models. It's like a digital fortress, completely sealed off.
So let's zoom out for a second, because this is way bigger than just one software deal. What this really signals is a huge shift. We're seeing governments starting to embrace and, normalize using this kind of cutting-edge AI. From OpenAI's point of view, their goal here is to get ahead of the curve. They're saying that by jumping in and working directly on projects like this, they can help write the rule book. They want to help set the standards for how to use AI safely and responsibly, especially in a place as sensitive as the government.
And all of this leaves us with one massive lingering question. We're moving past the what if and into the what now. As AI becomes just another tool in the national security toolbox, what new rules do we need? What new ethical lines do we need to draw? This partnership isn't just about code, it's about starting a conversation that we absolutely need to have, and it's putting it right at the top of the agenda.